I'm glad that you're here because today's lesson is probably the most important that we've done so far. It's not hard. When I say important, people are like, oh, no, but no, it's really not hard. It's just one of those skills that will take you all the way from this to the end of the year. Like it's kind of like one variable stats in the calculator. Like that needs to be fluent at some point. Enter the numbers in, stat, calc, whatever. We're gonna use that all year. This is another thing we're gonna use all year. Promise you, it's not hard. It's not a big deal. So, but glad you're here because it's important. We are going to be using colored pencil. I'm going to use a straight edge because I'm a nerd. We're going to use three or four of these guys in your packet, just for reference sake. So just so you have everything you need. Notes are not super long. I just want to go slow because it's so important. Okay. What proportion of bottles are filled with the amounts between 498 and 504? Okay, so if I look back at my graph from yesterday, which is down here, 498 and 504 are not exactly on the standard deviation lines. 498 is a little bit in front of 498.4, and 504 is a little bit past 503.8. Now I can make an estimate from yesterday's that I think it's going to be around 81.5% of the area, but I don't know for sure. So we need a way to figure out how to find the percentages without just adding up the ones that were given in the empirical rule. Back here on my big normal curve whiteboard, I labeled the problem that we're working on with those soda bottling plants. So I put all of the mean and the standard deviations, and I put the approximate. Notice I put the approximate symbol in there for the percentages. But I like to use that to help me make sure my answer is reasonable. Okay, there is a function in your calculator that you need to be able to do this. And it is located in the distribution menu of your calculator. This is probably the first time that you will access that. It's called DISTR. And you get to the distribution menu by hitting second vars, which is not vars, it's variables. But anyway, so second vars. And we're going to use almost all of these things all year, except we're not going to use normal PDF, and I'll explain that. What we want is normal CDF. So if you guys could find normal CDF for me. And hit enter. And it's going to ask you for some, you guys probably don't have numbers in there because you weren't just doing stats for fun on the side, but it's going to ask you for some values to type in. And it wants to know what your lower bound is, your upper bound, your mean, and your standard deviation. In this problem, the lower bound is 498, and we're actually going to write these on the side over here. Our upper bound is 504. And then we have the mean and standard deviation from yesterday. And the standard deviation from yesterday. Do those numbers make sense from what we did yesterday? It wasn't yesterday. It was Wednesday. Last year I had my stats class on Thursday. I'm gonna have to get used to that. But do you remember those numbers from when we made the okay? So 498, 504, 502, 1.8. Okay, now this is important right here. You can hit enter if you want. It's going to give you an answer. but you need to write this thing out in the parentheses with the commas, and you need to label it if you did not write the stuff on the side. So College Board is very, very picky. Because the calculator will do the work for you, the way you show your work is the calculator entry labeled. So we write normal CDF 498, 504, 502, 1.8. Does anybody have a really, really older calculator that did not give them the menu of things to type in? So you're just going to type this and not that. I don't know why Texas Instruments thinks that we can't handle typing 4 numbers with commas between and has to give us a menu of stuff. It's completely pointless, but whatever. Okay, so I'm going to put low, high, mean, standard deviation. Okay, so when you're doing one of these problems or an FRQ, if you're doing an MCQ, it doesn't matter. If you're doing an FRQ and it says show all your work for credit, you need to show either this with the stuff like laid out and labeled, or the arrows with that stuff labeled. You don't have to do both, just one or the other. There just has to be some kind of identifier of what each piece is. And then you need to write the calculated syntax, which is with the parentheses and the commas. Like all of this, I promise you it's worth it to make sure we have the details correct, because College Board doesn't mess around. Okay, so 0.8536. And this should be satisfying to you because we already calculated the ones on the standard deviations themselves yesterday from here to here, and it was about that same answer. So what I'm saying is you can use this in every single problem, not the, the labels for, I labeled this for the soda thing, but to see if your answer is reasonable before you walk away from the problem, you can actually like visualize where they should be. And before you leave the problem, you can make sure that you're correct, and if it makes sense. Okay. Now we're going to start to do some variations on that. So that's easy. That's like, if you're playing a video game, that's level 1. Okay, now we're going to do this guy. What proportion of bottles are underfilled? Underfilled is less than 500 according to the word problem that we cut out and put in. So we're going to take one of these. Do you guys understand where these numbers are coming from? So from Wednesday, we're given a mean of 502 and a standard deviation of 1.8. So I went up 1.8, up 1.8, up 1.8, and then I went down 1.8. Down 1.8. Okay, so now I'm going to take my straight edge and locate about where 500 is. I'm just going to go a tiny bit in front of the 500.2. And then, because I can, yes, honey. Because I can, I'm going to shade that portion. Okay, so now I'm going to, this is like one of those things that will trip you up all year if we don't go super slow and careful. You guys are like, what's the big deal? Well, we have to read this problem. It says, what proportion of bottles are underfilled? And I wrote this for you to help. Less than 500. So that's the area that I shaded. So I made 500 right there, and then I shaded less than that. However, what I want you to do is put a ray underneath. So I want you to put a dot at 500 and put a ray underneath that represents the fact that you understand that the normal curve goes on forever. It looks like it cuts off in our picture. It looks like it cuts off in our picture up there. The only little indication to you that it goes on forever is that arrow. But then in this clip art, they left like the little segment. I don't like that, but it's fine. Okay, so what I need to tell you is that this is negative infinity and this is 500. Okay, now your calculator, unless you have a TI Nspire, will not have negative infinity in it. It's not a button that we have. So what we do is we say negative 10 to the 99th power for negative infinity. It gives us a close enough estimate to be able to get our decimals correct. So when you guys have infinity or positive infinity or negative infinity, you're going to put negative 10 to the 99 in the calculator. Okay, so that's the low. So looking at my ray here, that's the low, that's the high. Can you tell? Okay. And then exciting that we get to use the same mean and standard deviation because we're using the same context. Again, I just wrote that wrong. Because my brain went to the fact that technically you don't need to label the mean and standard deviation again, but I think it's just a good habit to do it every time. Okay, so let's see what that looks like in the calculator. So I'm going to go remind you guys, second var, so it gets you into the distributions menu. And as you know, we do a lot of distributions in this class. Normal CDF, negative 10 to the 99th power, 500, and then it lovely leaves the mean and standard deviation in there for us lazy people. Zero 0.1333. Yeah. Mhm. Mhm. Yep. With a comma. So the comma is right above the 7. And then there's your second grade conclusion sentence. Now, does that make sense visually? So go back to your picture that you shaded in. Does it look like that's about 13%? Yeah, ish. Do you see what I'm saying? Like you can go back to your graph and check for reasonableness. Okay, now the next thing I need to do while you're setting up your notebook, this is a bad idea because research shows that students cannot listen and write at the same time. But I'm just going to violate that because this is not super important. I want to explain what normal CDF stands for so that you're not just willy-nilly using something to calculate it. Normal means normal curve, bell-shaped guy. C means cumulative. D is density at this function. normal cumulative density function, which means that it adds as it goes along the bottom. So you're thinking to yourself, okay, she said this was a density function. I understand that it's cumulative because I'm adding along the bottom as I go. What does normal PDF mean? And normal PDF is normal probability density function, which is just going to give you one spot. It's not going to give you an area. The only reason it's in there is to graph it on the graphing calculator, and I don't think I've ever graphed a normal curve on the graphing calculator. If you're bored at home tonight, you can YouTube it, but we will never use normal PDF in here. It's just not going to touch it. It's just going to sit there with cobwebs on it. We're just going to gloss over, scroll down one every time. Okay. What percent of bottles contain more than 503.5? All right, so wash, rinse, repeat. If you're thinking to yourself, gosh, it's kind of a long process to like graph all of these all the time. You're gonna get so used to doing this that you won't do the sketch. But for these first few, I need to be really careful. Okay, how did I know to shade to the right and not to the left? What does the problem say? More than, yeah. Okay, so draw your ray in when you're ready. And you'll see why I wanted to do this. So 503.5 is here, and it's going upwards, which means that we're going to infinity. And now the things switch. This is the low, and this is the high. Do you see what I'm saying? You picking up what I'm laying down? So you actually have to put some thought into, oh, which one's the low, which one's the high. So we're going to use positive 10 to the 99 because we're going to positive infinity. Okay, let's see what we get. 0.2023. Supposed to be a 3. Okay, can you guys look back into your notes? I want you to look back to the very first notes that we did and tell me what I highlighted next to percentile. I highlighted something. Hopefully you highlighted it too. It's the 2.1A section. It says percentile, 2.1A percentile. And I highlighted something. Yes. Less than or equal to. Beautiful. So when you see that word percentile, your brain needs to translate this to less than or equal to. Okay, so the graph for this is saying what percent of bottles are filled up less than or equal to 499. So where is 499 on the big curve? Like right here-ish, like right there. So we're expecting this to be 2.5-ish. Does that make sense? Like reasonably speaking? Okay, so just to check our answer. Now this one is a less than. So here's my question. I want to not graph it. I want to not shade it. I want to not label it. If it's a less than side shaded, what is the low? Negative infinity. Beautiful. And that's where I want you to be able to go. I want you to be able to do that quickly at some point, not today, of course. Zero 0.0478. Does that sound about right? Okay, so that's basically all of the normal CEF type questions you will be asked. Sometimes you'll be asked for between 2 points, sometimes less than, sometimes greater than, and then I threw that percentile in there just to revisit 2.1A's definition of percentile. Okay, now we're going to go backwards. How do we find locations within the normal distribution given the area under the curve? Okay, the lowest quartile of amounts of cola filled into the bottles is at how many milliliters? Okay, this I kind of threw a challenging one out here, but if you could take this word and change it to a percent, it will be helpful. Okay, and I feel like if I remember correctly, this little piece plus this little piece plus this little piece adds up to be 16. So 25 is going to be somewhere in here. We're making a guess at the moment, not a guess, educated guess. Oh man, this is crisis moment. My colored pencil of choice seems to be needing of sharpening quite a serious fashion. I don't know what's happening to my brain. Is it Friday? So this question is asking what value on the x-axis is it when 25% is shaded? And it said lowest 25%, so I knew to go to the left. Okay, so there is a calculator function for that too. And it's located in exactly the same spot. And it's called inverse norm. Inverse meaning go backwards normal. Okay, this is where I have to apologize. If you have an older calculator, this is going to be significantly more difficult for you than if you have a new calculator. So we'll see. We'll see. Okay. Go into inverse norm. And mine has a menu that asks for the area, mean, standard deviation. And then in the new calculators, you get to pick the direction of the tail. In the old calculators, they don't give you a choice. It's just left. Left is your only option. Okay, but in this case, our area is 0.25. Make sure to put that in as a decimal, otherwise it will laugh at you. Your mean is 502. Standard deviation was 1.8. And in this picture, my tail is going to the left. And it's telling me that value on the x-axis would be 500.8. Does that look about reasonable for my drawing? Okay. So if you have an older calculator, there's nothing different right now. You'll see. And if you have an older calculator, you're just going to end your parenthesis right after the 1.8 and ignore the direction. And then don't forget your units. Okay, you guys, need more time? You're good? Okay. Okay, so let's read this. How many milliliters is in a bottle at the 95th percentile? Okay, so what does percentile mean? Less than or equal to. So which direction will the tail be? Left. Okay, so translating, this is 0.95, and this is saying left. I'm not going to draw another one for this because this is left again, but does that make sense? Do you see my translations there? Okay, so inverse norm, 0.95, 502, 1.8 left. I'm gonna make it 505.0. What do you guys think? 505.0? Okay, so this last one, well, not this last, this is the last one we're gonna actually make a sketch of, but we have two more after because I have to cover every single possible question they might ask you. So let's figure out in a reasonable way where to put our line. So this we said was 2.5, and this we said was 16. So, I mean, it doesn't have to be perfect because we're just using it to check for reasonableness. So I think we said this section, this baby section plus this section was 2.5, and then to here was 16. So I'm just gonna go here-ish. And does my going to the right make sense? Okay, so if you have the older calculator, this is where you're gonna have to start thinking with your brain. No, not thinking with my brain, Mrs. Salvit. Okay, so we have top 10%, so 0.10 is my area, 502 is my mean, 1.8 is my standard deviation, but my tail is going to the right. Did I forget my milliliters up here? What is happening? Okay, now people with the older calculators, let's discuss. Your calculator only works in left. It doesn't like right. It's left only. It's like a NASCAR driving car. turn left only. That one person found that funny. Left turns only. Okay. So what you have to do is say, I don't want the upper 10%. I want the lower 90%. So in your calculator, you're going to do inverse norm 0.90 502 1.8. You see why that requires brain power? Ugh, instead of just being able to click right. Ah. So, okay. Last thing. The middle 90% of amounts of cola in the bottles is between what two amounts? Okay, so did you notice there was another option in the newer calculator? Center. So when I say the middle 90%, I'm saying center 0.90. Now, if you have a newer calculator that does not have this option, a lot of times you can download this update into your calculator. That would be a YouTube type situation, not a Mrs. Talbot type situation. But it is possible to update the operating system of your calculator. Okay, notice it gave you two answers. Does that make sense? You're talking about the middle 90%, so it's between what two numbers? So 499.0 5050 milliliters. Okay, now let's talk about it for students who have the older calculator. I'll show you what to do. If you have the older calculator, just make this little baby sketch over here. It's not that big of a deal. I'm making it out to be a big deal. It's really not that big of a deal. Okay, it's just because I don't, brain. Okay, does my little sketch make sense? Middle 90%. Okay, knowing that your calculator only works in left, you have to put in this spot separately and this spot separately. So you have to do it twice with that first line and that second line. Okay, let me ask you this. If it's 100% under the curve and I took up 90 with the middle, where's this guy at? 5%, 0.05 for this section. And then remember your calculator works left. So what would it be cumulative to here? 0.95. So if you do your two inverse norms, one with this and one with this, then you'll get those two numbers. What? Okay, so like you're gonna go inverse norm. Let me see if I can do it without the. Can I see yours? Because there's multiple people who need it. Okay. So you're gonna go 0.05 mean 0.05. And that will give you this one. And then you're going to go 0.95. And that would give you this one. You have to do it twice, once with the low, once with the high. So this guy and this guy. I can do more practice with you later if you want. There's a whole worksheet on this. And you and I can sit down and work on it if you want to. Or you can borrow one of my calculators when you have to do this. whatever. Okay, last thing. What is the z-score at the 70th percentile of filled bottles? Okay, last thing. Z-score. We need to translate that. We need to translate this. And we need to translate this. What is 70th percentile? What does 70th translate to? Yep, so 0.70. What does percentile translate to? Less than or equal to, which means your tail is to the left, which is good for the people with the older calculator. When it's left, you don't have to do anything special. Okay, now z-score. What does that translate to? So look at the big magnet. The z-scores are the big numbers that you could read, like even if your vision is terrible. Like it's one of those eye charts. Do you see the z-scores, the big numbers? Okay, what that means is the mean is 0 and the standard deviation is 1. When it says z-score, you have to translate it to that. Okay, so inverse norm. 0.70, 0, 1, left. 0.5244. I'm going to put z equals on the front. But let's check last thing. And then I'm done. Oh, I do have a joke for you though. But last thing, does that make sense? If it's 70th, so this is 50, right? And this is 86. 70th would be right about here, which would be like halfway between the 0 and the 1. So the 0.5 makes sense. Okay. Last thing is your joke. Am I ready with it? I am. What do you know? Okay. Did we solve problems finding the area under the normal curve and finding the location given the area? Yes, indeed. Your homework is 53 to, why is this here? 53 to 59 odd, 60, 61 to 67 odd. And there is your joke. Normal distribution, paranormal distribution.